Today's lesson is on graphing quadratic functions in the form f of x equals a times x minus h squared plus k. This form is called vertex form. So what I need you to do right now is write down right here, please, that this is vertex form. Okay? Now the nice thing about this form is that if it's written this way, then you can identify what the vertex is immediately. So what I want you to do first of all is open up your calculator. We're going to just look at a couple examples and then we will move on and find the vertex for each of the examples that we have on our paper. So if you could open up a graphs page, and then I'm just going to randomly make up an example. So let's do 2 times x minus 4 the whole thing squared plus 1. Now if you look right here, let's actually go through menu, analyze graph, minimum. Let's go to the left of the minimum, the right of the minimum, and it tells you right here that the minimum is 4, 1. And if you look at the equation, right here you've got x minus 4 and the vertex is 4. So it's the opposite of what's inside of here. And then this 1 right here is a positive 1, and the vertex here is positive 1. Now you normally would look at this and think that it is the y-intercept, but it's not. The y-intercept is way up here. So be careful, because this right here, remember when you multiply this x minus 4 out right here, by itself, it's going to turn into a constant. You're going to double that, and you're going to add 1 to it. That would be your y-intercept. But when it's in this form, this extra 1 here is the y half of your vertex. So let's try another example. So I'm going to go up here, and I'm going to change this to negative x squared plus 5. So what I'm going to do is I'm going to analyze the graph, find the maximum this time, go to the left of it, go to the right of it. The maximum in this example happens to be the y-intercept. It's just a coincidence. I'm sorry, excuse me, it's not a coincidence. It's just in this specific problem, it is the y-intercept. It's not always going to be. So if you notice right here, there's nothing added on to this x that's being squared, so that nothing translates to this 0 here, and then this 5 is the second half of your coordinate. Let's try one other example. Let's do x plus 2 squared and then plus nothing. So let's find the vertex here. This one is a minimum. So I'll go to the left of it, then I'll go to the right of it, and the minimum is at negative 2, 0. So right here, this plus 2 translates to this negative 2 in your vertex, and then nothing is being added onto it, so the y half of your vertex is 0. So we're going to use all of this information to help us find the vertex when my equation is in vertex form. So let's go ahead and find a spot on your paper on these notes, and I want you to write out what vertex form is one more time, just so that it's a little bit clearer on your paper. So vertex form is f of x equals a times x minus h squared plus k, and your vertex is always going to be hk. Okay, so it's the opposite of whatever sign is here, and then this k right here is the other half of your vertex. So let's go ahead and write it out one more time right here. I'm going to write it on my paper. You don't have to write it again because it's already on your paper. So it's a times x minus h squared plus k. And I know that the vertex has to be hk. So in this example, in number 1, I'm going to look at this right here. The a is 1, the h is 5, and the k is 11, which means that it passes through the vertex at 5, 11. I'm just going to graph this out once just to make sure that it really is 5, 11, and then we'll do the remaining 3 without using our graphing calculator. So I'm going to type in f of x equals x minus 5 squared plus 11. I probably won't be able to see the vertex that well, but I am going to change the zoom on my calculator. So I'm going to try something different. I'm going to go to zoom fit and see what happens with that. And I can kind of see the vertex. I mean, I can't see the full parabola, but for the purpose of what I want to do right now, I can see the vertex. So I'm going to go to Menu, Analyze Graph, and then I'm going to go to Minimum. I'll go to the left, to the right, and then the minimum is right here. Let's drag it so we can see it. 511 truly is the minimum, so that means that it works. Now, one last note that I want to make is that we know this is a minimum because the A value is positive, so we're going to indicate that this is a min. Okay? So go ahead and try 2, 3, and 4, see what you get for your vertices, and then we will compare with each other once you're done. So go ahead, press pause, and come back when you're ready to go. All right, so in number 2, the H value in number 2 is positive or negative 3, and the K value is negative 1, which means that my vertex is negative 3, negative 1. Because the A value is negative, it means it's a max. Okay? In number 3, the H value is 0 because nothing is being added on to this x squared right here. And then the K value is 10, which means that the vertex is going to be 0, 10. The A value is positive, which means that this is a minimum. And then lastly, in number 4, the H value is positive 2, the K value is 0 because there's nothing there, which means that the vertex would be 2, 0, and this vertex would be a max because the A value is negative. Okay? All right, lastly, this question asks us to find the axis of symmetry and vertex of each quadratic function using 2 methods. 1, the formula for the axis of symmetry, and 2, completing the square. All right, so the first method asks us to use the axis of symmetry, so I'm going to say x equals negative b over 2a. So that means x equals negative 2 over 2 times 2. So I get negative 2 over 4, which is negative 1/2. So then I have to figure out what f of negative 1/2 is. So I will get 2 times negative 1/2 squared plus 2 times negative 1/2 plus 8. And I just have to follow order of operations to figure out what this is. So I end up getting f of negative 1/2 equals 2 times 1/4 plus 2 times negative 1/2. Sorry, that's a plus sign. Plus 8. So then I end up getting 1/2 minus 1 plus 8. Put it all together, that means f of negative 1/2 is 7.5, which means that my vertex is negative 1/2, 7.5, which is a minimum because the A value is positive. Well, because it allows me to put this function in the format, in the vertex form, because it ends up being a perfect square plus an additional constant. So just like we've done before, I'm going to factor out the 2 for my first 2 terms, for the 8x squared plus the bx, and then I'm going to keep the 8 on the outside. All right, then I'm just going to take my b value right here, cut it in half, and square it. So I end up getting 1/4 right here. So this is plus 1/4. Now don't forget that this is 2 times 1/4, so it's really 1/2. So to get rid of it here, since I'm adding it here, I got to subtract it on this side, on the same side. So remember, you do the opposite when it's on the same side. Then I can go ahead and get rid of, or excuse me, I can go ahead and factor this right here. So I can say f of x equals 2 times x plus 1/2 squared. Remember, this 1/2, when I square it, gives me 1/4, and when I double it, gives me 1. And then combine your like terms right here, and you get 7.5. It's now in vertex form, which means that my vertex is negative 1/2, 7.5, just like we figured out the other way. So you can use both methods to find your vertex, and we can say that this right here is, again, a minimum because the A value is positive. Okay? And that's how you use vertex form.